Alright guys, so we're going to apply our properties of logarithms, properties of logs. Three main properties. The first property is if you have a log with multiplication in it, you can break it up with addition. If log base b of m times n is the same thing as log base b m plus log base b of n. And it also works the other way. If you have two logs that are added together, you can make it one log by multiplying the two numbers. Quotient property, same thing as you would think. If you have log of division, you break it up with subtraction. It works the other way also. If you have two logs that are subtracted with the same base, you can make it one log by using division. And the power property. If you have a log that's an exponent in it, you can take the exponent and put it in the front like we see right here. The other thing to think about there is if there is a number in the front like this, it represents the exponent of the number with a log. Now, if you think about those properties, those are just the inverses of the exponent rules. Remember with the exponents, when we multiply, we add. When you divide, you subtract. When you have a power to a power, you multiply. Same thing. Okay, sorry about that. Next thing I'm going to have you do is work out. They're going to tell you make you use the properties. They're going to tell you what log base 4 of equals 0.792 and log base 4 of, I didn't write that out correctly. Sorry about that. It should say log base 4 of 3. I was about to say we can't do it like it's written. That should be a 3 right there, and this one should be a 7. Sorry about that. Who typed this thing up? I did. Okay, so now we can do it. The first one says log base 4 of 3/7. Remember, when I have division, that means I can break it up like this. I can do log base 4 of 3 minus log base 4 of 7. That's what the property said. You know, if you have division, it represents subtraction. Log base 4 of 3 is 0.792. Log base 4 of 7 is 1.404. I'll take my calculator, you'll probably hear me, and subtract those real quickly, and I get negative 0.612. That's a terrible 612 right there. We're trying to get 612. There you go. I'm going to punch it in and make sure you get the same thing. All right, let's try the second one. Second one says log base 4 21. Now, what I've got to do is I've got to figure out how to get 21 using 3 and 7. That's not really hard. If I do 3 times 7, that is 21. All right, now, so I have multiplication in there. Because I have multiplication, I can break that up using addition. I'm going to say log base 4 of 3 plus log base 4 of 7. Okay, last time I did subtraction because I had division. This time I'm using addition because I have multiplication. Log base 4 of 3, remember, is 0.792. Log base 4 of 7 is 1.404. If I punch those in and add them up, I get 2.196. And there's that one. And the last one, part C, log base 4 of 49. 49 is really 7 squared, and the reason I wrote it like that is because I have to use either a 3 or 7. That's all I know. Remember where the exponent goes. The exponent ends up in the front always, just uses multiplication. So I'm going to do 2 times log base 4 of 7, which I know from the direction is 1.404. So if I multiply that by 2, I get 2.808. All there is to it. All right, this one says expand. When it gives you stuff like this, it wants you to write it out as long as it takes you to write that out. And the first thing I have is this. First thing I notice there's division in there. So I'm going to say log base 6 of 5x cubed minus log base 6y. So I got rid of the fraction bar by doing subtraction. Now if I'm looking at this one, it has multiplication in it. So I'm going to break it up too. Like log base 5 plus log base x cubed minus log base 6. Wow, I got my 6 right there. Okay, now it would be done, except I noticed this log right here has an exponent, which means the exponent, remember, always ends up in the front. So I'm going to put the 3 in front of the log base 6x minus log base 6y. And that's expanded. That's as far as I can take it out. Okay, now this one's just the opposite. It says condense. So I'm going to try to make this one log. Now, one thing I'm going to say here that isn't really, we haven't talked about yet. Notice there's no base written on any of these logs. Anytime you see a log with no base, automatically that means base 10. It's just understood, base 10. And it's a great log because your calculator actually does base 10. Like there's a log button on your calculator, it does base 10. So let's just go through here. First thing I see, there's a 3 in the front here. That's really the exponent on the 2, so it's going to be 2 cubed. 2 cubed is really 8. I guess I'll take a step. You could have done this in one step, obviously. 2 cubed is 8. I'm going to go ahead and write that there. Now I have these first two logs that are added together, which means it represents multiplication. 9 times 8 is 72 minus log 3. Now I have two logs that are subtracted. Subtraction means you divide, so we'll do 72 divided by 3, which is really just log 24. And we can shorten that a lot. I just want to show you kind of how all those properties keep on working. All right, last new thing here, change of base form is going to end up being one of your favorite things. You were allowed to change a base of a log just by doing this right here. If you have log base C of A, you can always write it log A over log C and use any base that you want to, and that's going to be a really nice tool as we go on. This one says in particular, if you have log base C of A, do this. Remember, notice there's no base there, which means it's base 10, which means we can change anything to base 10 that we want to and let your calculator do it. Your calculator also does natural log, so we can change things to natural log A and natural log C as well. All right, so those will be the two biggest ones that we do because that's what your calculator does for you. One more slide. All right, this one says evaluate log base 3 of 8 using common logs and natural logs, right? So log base 3 of 8, if I do common logs, you just do log 8 divided by log 3. Notice I didn't put a base, which means it's base 10, which is what I want because your calculator and my calculator too will do the base 10 for you. Also going to write natural log 8 over natural log 3. Now if I were you, if you have your calculator handy, I'd practice punching those in. So I'm going to go ahead and punch through. I'm going to hit log 8. Now when you do that, make sure you close your parentheses divided by log 3. When you hit your log button, a parentheses automatically opens. You need to get in the habit of closing them. I get 1.8928. Now I'm going to do the same thing with the other one. I'm going to do natural log 8, close your parentheses, divided by natural log 3, close parentheses. The same thing, because it doesn't matter which base you change it to. You can change any base you want as long as you do the same base on your numerator and denominator, and you'll get exactly the same answer. Could have base 2, doesn't even matter. All right, so shouldn't be too bad today. Hope that wasn't hard, and we'll work on it in class tomorrow. See you then.